Welcome to lesson 4 of matter 2. The title for this lesson is naming compounds, and the question for this lesson is what is a compound and how are they named? The keywords for this lesson are atom, element and compound. So first of all, we have a knowledge check to complete, so make sure that you pause the video and give yourself enough time to answer all 8 questions before the answers appear. Here are the answers. So the number of elements in the periodic table is 118. The 2 groups that the elements can be divided into are metals and non-metals. The scientist who developed the modern periodic table is Dmitri Mendeleev. He was a very important man, very smart. The 2 scientists who developed the model of the atom in 1911 are Rutherford and Marston. Again, very important people that you need to know. So the relationship between the number of protons and electrons, in an atom there are the same number of protons and electrons. The overall charge of an atom is neutral. This is because atoms have the same number of protons and electrons. Because they have the same amount of negative charge and positive charge, they cancel out, so there's no charge overall. Atoms become ions by either gaining or losing electrons. And the reason why some atoms become ions is because they are reactive. They have an incomplete outer shell and they want to fill that outer shell. So in order to do that, they gain or lose electrons and become ions. They become charged, but they become stable because then they get that full outer shell that they want to have. Make sure that you mark your work and give yourself a mark out of 8. So, let's talk about compounds. So when we get 2 or more different elements chemically combining in a reaction, we call it a compound. So for example, the best example that I can probably give is water. So water is a compound because it's made up of hydrogen and oxygen. Carbon dioxide is also a compound because it's made up of carbon and oxygen combined together. So these should be familiar examples of compounds, but of course there are so many examples of compounds. Now for this lesson we will be learning about metals bonding to non-metals, but there are other combinations too. An example of that is non-metals and non-metals. They combined together as well. But this lesson we will just learn about metals binding to non-metals. Now when a metal binds with a non-metal, we call it an ionic bond. It's a type of electrostatic force of attraction between the 2 elements. And it causes the 2 elements to combine together. It's a bond, it links them together. Now, in terms of identifying the compound and naming them, we can easily identify compounds because they don't exist on the periodic table. So if you have a look, water is not on the periodic table, and neither is carbon dioxide. That is because compounds are made up of elements, and elements are shown on the periodic table. So you can see the elements that make up water and the elements that make up carbon dioxide, but the compounds themselves are not on the periodic table. Now in order to name a compound, you typically use the names of the individual elements it is made from, but that is not always the case. Sometimes they get a completely new name, which is also then not on the periodic table. But most of the time, you just use the names of the individual elements. No matter how many elements there are, you can use those names. So here we have our first learning activity. So use your periodic table to try and see if you can work out which of these are elements and then which of these are compounds. Put an E for element and a C for compound. Make sure that you pause the video to give yourself enough time to do it before the answers appear. Okay, so here are the answers. It might be easier for you to see it this way with just the letters, but I then also have a version where they are coloured in to show the difference. So I will then go to the coloured in version, but if you prefer to use this one, then please do use that to mark your work. So here is my coloured version where you can see the elements versus the compounds. So most of them are elements that you can find on the periodic table. Some of them you have the names, so potassium, neon, gold, those are the names. Some of them you have the symbols, so you have Ca, which is calcium, Pb, which is lead, Al, which is aluminium. Then you have ones like H2, Cl2, O2. Now, because there's two of each one, so there's two atoms of each, but they are still the same element, we then call that still an element. They have to be, in order for it to be a compound, it's got to be different types of elements, so different elements bound together. H2, O2 and Cl2, they are all molecules because there's more than one atom put together, but they are still just one element. They are not a compound. Whereas if you look at water, carbon dioxide, glucose, methane, all of these are made up of combinations of different elements. So methane is carbon and hydrogen. Carbon dioxide is carbon and oxygen. Water is hydrogen and oxygen. So all of these things, you use more than one element from the periodic table to make them. And I've also then matched up where the symbol matches with the name. So water is on here twice, oxygen is then on here twice, and glucose is on here twice. So you can then see where sometimes they've used the name but then also the symbol, and you can see that with water is made up of hydrogen and oxygen. Glucose is made up of carbon, hydrogen and oxygen together, and of course oxygen is then just an element, it's just made of oxygen. These are examples where the compound isn't necessarily named to do with the elements that it's made up of. Whereas the examples that we're going to look at today are just using the names of the elements. So these names are quite complicated, like water doesn't have anything to do with hydrogen or oxygen. But to be fair, the scientific name for water would then be hydrogen oxide. Well, it would be dihydrogen oxide, so 2 hydrogen, 1 oxygen. Okay, but let's not get into that. So we are going to look at some more simple examples where the names actually match up with the elements. So in terms of ionic bonding, so when metals and non-metals bond together. Now many types of atoms have incomplete outer shells, which makes them reactive. They are unstable. Metals will lose electrons to become positive ions, whereas non-metals are the opposite. They will gain electrons to become negative ions. Remember that electrons are negatively charged, so if you lose them, you become more positive, but if you gain them, you get more negative charge. So the objective of this is to complete their outer shell and become stable. Now, oppositely charged ions are attracted to each other by an electrostatic force. This is what I was talking about earlier. So just like negative electrons are attracted to the positive protons in the nucleus, opposite charges attract. So a negative ion and a positive ion, like a metal and a non-metal, will be attracted to each other. That electrostatic force between them forms what we call an ionic bond. It's a similar thing that you would see in terms of poles on a bar magnet. Opposite poles, so south and north pole on a magnet, attract each other. They are opposites. It is the same like that for charged ions. If they are opposite, then they attract. Now, let's have a look at naming ionic compounds and how we make them. So, we have seen that the metals become positive ions and non-metals become negative ions. The number of electrons that each lose or gain has an effect on the size of the charge that those ions have. So when ionic compounds formed, that means that a metal ion and a non-metal ion come together, they are attracted to each other by an electrostatic force. We name them by combining the name of the metal first and then the non-metal second. And we just combine those two names for each of the elements together. Now, for some non-metals, the name slightly changes between the atom and the ion. So we have an example here. We've got a sodium ion that's combining with a chloride ion. Remember that chlorine is the atom, chloride is the ion. So you then make sodium chloride. Now we have a table underneath then showing what happens to the charge when we lose and gain electrons. So when we lose more electrons, we get an increase in positive charge. When we gain more electrons, we get a gain in negative charge. Remembering that electrons are negatively charged, so if you lose them, you're more positive. But if you gain them, you become more negative. You are gaining negative charge. So here we have our table of different types of ions. So on the left we've got metal positive ions. Notice that hydrogen is part of that table when it's not actually a metal. That is because it forms a positive ion. So even though it's not a metal, it's the exception. It still forms a positive ion even though it's a non-metal. On the right you then have the non-metals that form negative ions. Now as you can read above, the charge is written in a particular way. So notice how the charge, positive or negative, is written in small above where you would normally write. So notice how in Na we write the A at the bottom, but then the charge is at the top. We don't write it where we normally would write. That is called superscript. It just means writing above. So, when we write charges, we write the charge superscript. We write it in small up above, so up high. So imagine that it is flying in the air. That is our charge. So charges fly up in the air. You must make sure that you write your charges that way. That is the correct way to write them. Now let's have a look at the questions. So the following elements are not found in the first 20 of the periodic table: copper, lead and zinc. And it says write the names of some ionic compounds using the three metals above and the non-metals in this activity. So what you need to do is you need to have a look at those three elements and then try and combine those with some non-metals in the table to make some ionic compounds. Remember that the name of the metal comes first and then the name of the non-metal comes second. Make sure that you pause the video to give yourself enough time to then answer this question. Okay, so these are examples of some of the answers that you should have. So using copper, lead and zinc to make some ionic compounds, we have then some examples. So copper chloride, lead fluoride, zinc sulfide, lead sulfide, zinc oxide, lead chloride and copper oxide. Okay, so I have at least used each one of the negative ions, the non-metals, at least once to give you an idea. So as long as you put the metal at the start of the name of the compound, so before the non-metal, then you are doing it correctly. And just be aware of those changes between the atom name and the ion name. So atom name would be fluorine, the ion name is fluoride. The chlorine would be the atom name, chloride is the ion name. So just make sure that you're getting those correct as well. Make sure that you mark your work. I'm sure that your answers are perfectly good. Okay, so now we move on to the next activity, which is again very similar. So now it's giving you the metal ion name and the non-metal ion name. All you need to do is put them together then to make the name of an ionic compound. So it's the ionic compound that they would make when they come together. There is then a question underneath that you can complete as well. So make sure that you pause the video and give yourself enough time to answer all of the questions. Fill in all of the table and answer the question before the answers appear. Here are the answers. So we have potassium chloride, zinc fluoride, magnesium chloride, potassium oxide, we've got sodium sulfide, sodium fluoride, lithium chloride, calcium oxide, aluminium oxide. And then in terms of the question underneath, we've got some examples of other non-metal compounds. So we've got nitrate, hydroxide, carbonate and sulfate, and it's asking you to use a combination of metal and non-metal to make the name of some compounds. So I've got aluminium carbonate, zinc hydroxide, calcium nitrate and magnesium fluoride, but I'm sure that there are many other great examples of compounds. Again, as long as you put the metal before the non-metal, then that is the correct way to name the compound, the ionic compound. So last of all then, we have a knowledge check to complete. So make sure that you give yourself enough time to answer all 8 questions before the answers appear. So the overall charge of an atom is neutral, they have no charge. The charge of metal ions is positive charge. That is because metal ions lose electrons. It is easier for them to do that than gain lots of electrons. Now for number 3, we have naming an ionic compound starts with the metal first. You put the name of the metal element first and then the non-metal. The charge of non-metal ions is negative charge. They always gain electrons, or at least most of them do. Hydrogen is the exception. So they gain that negative charge by getting more electrons. The name of the force attracting ions together is electrostatic force, and that forms an ionic bond between the metal and non-metal ions. Because they are oppositely charged, they are attracted by electrostatic forces. A chlorine atom becomes a chloride ion. The name changes slightly, which is a positive ion. It's an example of a non-metal ion. the position of the charge when writing the symbol for an ion. So obviously ions have charges and you write them in a particular way. We call it a superscript. It means that it's written above in small writing. So just imagine that that charge is floating in the air. Okay, it's got a little bit of air underneath it, so it's up high, and that's why we write it above. For the last question then, the name of the electrons in the outer shell are valence electrons. Make sure that you mark your work, give yourself a mark out of 8, and make any corrections that you need to in a different coloured pen. We do have an extension question, so do pause the video to answer that question if you want to give it a try. Make sure that you give yourself enough time before the answers appear. Okay, so for this question is asking how many of each ion would be needed to make these ionic compounds. Now when we are making ionic compounds, we need to be aware of the charges of the ions that are being involved. Now when we want to make an ionic compound, we want the ionic compound overall charge to be 0. So that means if we are adding a positive and a negative charge, if they are even charges, then that's fine. That is okay. But if they are uneven, then you might need to add more of one than the other. So a good example of this is sodium oxide. Because sodium has just a charge of +1, but oxide ions have a charge of 2 minus, -2, we need 2 sodium ions to make up 2 plus to even out the 2 minus, the -2, because we're meant to be trying to make the charges equal. So for aluminium fluoride, aluminium ions have a +3 charge. Fluoride ions only have a -1 charge. So we need just one aluminium ion, but because it's got +3 charge and fluoride ions only have -1, to make it equal we then need 3 fluoride ions. For the last one then, potassium sulfide, potassium ions have a charge of +1. Sulfide ions have a charge of -2. So to make it even, we need 2 potassium ions for that 1 sulfide ion to make the charges equal. When we have the 2 potassium ions, it then gives us +2 charge, and then the sulfide ion on its own just has -2. It makes it equal. That is the idea of this question. You are needing to make the charges of the ions equal. And we will come back to this in later lessons, but obviously it's good if you can wrap your head around it now to make it easier in the future. So well done if you did have a good go at this question. Make sure that you make any corrections that you need to, and perhaps write some extra notes underneath to help you understand how you get the answers. That is the end of the lesson. Thank you.